Welcome to this video on partial fractions. Now we've got this one question here that we're going to do in two different ways to find the values of a, b and c. Okay, and we notice first of all that we have an algebraic fraction with a repeated factor on the denominator of x minus 3. Okay, and because of that we have to split it into fractions where 1 is over x minus 3 and the next one is over x minus 3 all squared. Okay, the reason we have to do that, just to be clear, is that if we were to write b over x minus 3 and c over x minus 3, okay, we might as well instead have just written a single fraction over x minus 3 and combine these two. And that wouldn't then give us the correct format for the denominator. So we have to do it like this. Okay, and we have to force that to equal this and then find the values of a, b and c. So if I just call this thing f of x to save me writing it down as it is over and over again. So if I call that fraction f of x, okay, I can now say here that f of x is going to be written as the sum of three fractions with numerators a, b and c. Okay, and it's going to be like this. They're all going to have a denominator of a common denominator, and the lowest common denominator of all of this stuff is x plus 1 times x minus 3 squared. So that's what I'm going to do. So I'm going to write the a, but next to it I need to write an x minus 3 squared as well. Okay, and that means I can write the denominator of that as the same as this, basically. So it's going to be x plus 1 times x minus 3 all squared. Okay, so x plus 1 brackets x minus 3 squared, like that. Okay, and then I'm going to add the next fraction, which is going to be b, and to adjust that I'm going to have to put both an x minus 3 and an x plus 1 next to it. Okay, x plus 1 and a single x minus 3. Okay, and then I'm going to have to put underneath exactly the same as what I've got here. Okay, so if I just put the fraction line in first, okay, like that, and then underneath that I just take a copy of this, okay, and I just copy it like that, take that copy and put it under here to save me typing it all out again. Okay, and then I've got one more fraction to add in, which is c. And the c's already got the x minus 3 squared on the bottom, so all I need with the c is the x plus 1. Okay, and then the denominator of that third fraction again is a copy of this. So let's just take another copy of this. Okay, and drag it across to here. And all of that is basically equal to f of x, which has the same denominator. All right, so this denominator, x plus 1, x minus 3 all squared, appears in all three of the fractions and in f of x as well. So in practice, we don't write this step down that I've done here in red. Instead, what we would do is just simply go straight to this statement. All right, so instead of writing all that down, we could have just written down f of x, not f of x, in fact, just the numerator of f of x, okay, which is x plus 5, okay, is equal to, now it's going to be a times x minus 3 all squared, okay, plus b times x plus 1 times x minus 3 plus c times x plus 1. Okay, so we wouldn't normally have needed to have written all of that down. I was just doing it to illustrate what's actually going on here. So I'm just going to put that in a big bracket to suggest to you that actually you didn't need to write all that down, but it's there for reference. Okay, you can do, of course, but it would take time, and it's not necessary. Okay, so there's two methods we could use here, all right? And the method that a lot of people use is equating coefficients. And in this case, it's actually quite long-winded to do that. There's a quicker way, but we will do the coefficients first. So what I'm going to do is just work on this like this. So I'm going to say that that's a times x. So this is x squared minus 6x plus 9, you see. Okay, the second part is going to be b, and that's times by x squared, and we're going to have plus 1x minus 3x, so it's minus 2x. Okay, we've also got minus 3. Okay, and then we've got cx plus c. Okay, and I'm just going to keep on expanding this stuff out until I get to a situation where I can equate coefficients. So I'm going to have a x squared, okay, plus, well, what I'm going to do actually is just slightly simplify this in one more step, because I've got an ax squared and a bx squared, so I could just write a plus bx squared. So they're going to give me the two x squared terms. Okay, otherwise there's a lot to write down. Okay, so all I've done is I've just used the ax squared and the bx squared. Okay, and I've got no more x squared stuff left. Okay, now I can deal with the x terms. Okay, and I've got minus 6a, minus 2b, and c. So if I put it like this, c minus 6a minus 2b, and that's how many x's I've got. Put that in a bracket and put the x next to it. And what I've now done is taken care of these terms here. Okay, the minus 6, the minus 2, and the c here. Okay, then I could go on and do the constants, and the constants are the numbers without any x terms. So I've got plus 9a minus 3b, so I've got 9a minus 3b plus c. Okay, and that is my constant term. So I've just taken care of these final three terms here, which are the 9a, the minus 3b, and the c there. Okay, and all of that equals x plus 5. Okay, so if we continue even further with this, we get that, so from the equating coefficients, a plus b must equal 0. Okay, because look, we've got no x squared term in here. So a plus b, I'll go up here with this part. So a plus b equals 0. Okay, a plus b equals 0, which means that whatever b is, a is the negative of it. So a equals negative b, or b equals negative a. Okay, so that's one equation we could make use of in a minute. Now, let's look at the x term. And I've got c minus 6a plus minus 2b equals 5. No, sorry, equals 1. Equals 1, because the x term has a coefficient of 1. All right, so I need to say that c minus 6a, okay, minus 2b equals 1. All right, because it's 1x plus 5. Now, I know that A equals minus B. So I could write the minus 2B as plus 2A. In other words, I could say that C minus, now if I write the 2B as plus 2A, it's going to be C minus 4A equals 1. Okay? Because I got minus 6A plus 2A here, effectively. So that gives me an equation now with just 2 variables instead of 3. And now I'm going to look at my third one, which is that 9A minus 3B plus C equals 5. Okay, so let me just write that down. 9A minus 3B, okay, plus C equals 5. And again, I could say that the minus 3B is the same as the plus 3A. Okay, so therefore that's 12A plus C equals 5. Okay, using this fact here. So 12A plus C equals 5. Okay, now if I just call those equations 1 and 2, I can solve them simultaneously. So if I subtracted this one from this one, so equation 2 take away equation 1, it would eliminate the C and tell me what A is. Okay, so C take away C is 0, 12A take away minus 4A is 16A, okay, and 16A equals 5 minus 1, which is 4, okay, which implies that A is actually a quarter. Okay, so A, B and C don't have to be integers, they can be fractions, and this one is. That's not a problem. And if A is a quarter, we know that B is the negative of A, so B must be minus a quarter. Okay, so we've already found A and B, we've just got to find C. If we substitute into, say, equation 1, so substitute into 1, okay, we could find what A is, couldn't we? Sorry, what C is. So if we sub into 1, we've got C minus 4A, which is 4 lots of a quarter, equals 1. Well, 4 lots of a quarter is 1, so C minus 1 is 1, so C must be 2. Okay, so my answer to all of this would be that f of x could be equal to, so let's put them in the right order, a over x plus 1. So it's a quarter over x plus 1, which of course we write like this, 1 over 4 brackets x plus 1. Okay, that's the first fraction. The second fraction, I'll put the little lines on in a minute. Now b is negative, so negative a quarter, so let me just put a minus sign in there straight away. So it's negative 1 over 4 x minus 3, okay? And finally, the c term, which is 2, gives us plus 2 over x minus 3 all squared. Okay, and that is they are the 3 partial fractions that make up that original f of x. Okay, now what we did there is we used the methods of equating coefficients. Okay, perfectly valid method, it works and it works well, and that's the result we get. Now there is another method, okay, and I'm just going to now show you what we could have done instead when we got to this point here. Okay, in fact what I'm going to do is take that whole line down and show you another way, which in this case would be a lot quicker. Okay, so let me just take this out from here. Let me get the selection thing, that one. Okay, so this line here, if I take all of that down, make a copy of it, and bring it down here, I'll work from here again, but do it in a different way. All right, so here we go. Let me just take that away, or separate that off. In fact, we'd separate the whole thing. Okay, so instead of that, what we do is we choose values of x that would cause pairs of these brackets to become 0. So for example, let's just take x equals, I'll do this in a different color. So let's just start with saying let x equal -1. So in other words, if x equals -1, right? So x equals -1. Okay, that would give us on the left-hand side, -1 plus 5 is 4. Okay, and on the right-hand side, what would happen? This bracket would be 0, and so would this one. You see, because if I put -1 for x in there, that becomes 0, and that becomes 0. So I would simply get that that 4 equals a times -1 minus 3 squared, okay, which implies that now -1 minus 3 is -4, okay, -4 squared. So 4 would equal a times 16, or 16a, which implies that a is a quarter. Well, we know that already because we did it over here, but it's now done in a different way, and in this case much quicker. Okay, the second one to find the second thing we do is this. We would now substitute x to cause this bracket and this bracket to go to 0. Okay, so that would be substituting x equals 3. Okay, so if x equals 3, okay, the left hand side becomes 3 plus 5, which is 8. Okay, and 8 would equal, now this bracket is now 0, this one is 0, so it would give you c times 3 plus 1, okay, which is this from here, because both of these brackets contain would be 0 and that would be 0, you see. So the only bracket that would have a value would be this one, and that means 8 equals 4c. Okay, so 8 equals 4c, therefore c equals 2, which we also know from earlier. Okay, now of course what we can't now do is from this find what b is. So we might have still needed to do some of the work that we did up here. Okay, but because we now know the values of a and c, we could have easily used that to find b. Or in fact, we could just look at this first term here and recognize that the x squared term has to be 0, so a plus b has to be 0. So if a is a quarter, b is minus a quarter. So there's a little bit of work to do there to find b as well, but that saved time in this case, I would say. So we know that b is minus a quarter, and therefore we get the same result as we had here. Okay, but this method is called, well, I don't know what it's called, a substitution method, I suppose. Okay, but it leads to the same result that we had earlier. Okay, so using either of those methods, just be careful with your algebra, and I hope that was helpful.